Hi there, and welcome back to the Digital Money Revolution. I'm your host, Chris Coney. Now, in this video, we're going to go into the question, what is cryptography? If we go back to our definition here, we now are almost there. We know that Bitcoin is an open source software protocol. We know that it enables a blockchain to be built on a trustless network that's decentralized. We know that we use the internet to do that. We know that we host a public database, which is the blockchain. And we know that tracks the changes of ownership of Bitcoins, which are the assets. And then finally, this is all secured by cryptography and consensus. So in this video, we're going to look at cryptography. So think about Pig Latin. If you've never heard of Pig Latin before, this is a little word game that typically children play. And they use it to communicate with either their brothers or their sisters so that their parents can't understand what they're saying. So they can sort of communicate in secret. So that the parents can hear the message, but they won't understand it. So it's a way of making the message appear meaningless, just like it's just meaningless sound. But that's not true. It's just because they can't interpret it. That's why it seems to be nonsense. So here are the rules of Pig Latin. You take the first consonant of a word and you move it to the end of the word, and then you add AY. So for example, the word pig, you'd take the P, put it at the very end of the word, and then you would add AY. So pig becomes igpay. Then, if the word begins with a vowel, then you just add WAY onto the end of the word. For example, apple, because that begins with a vowel, you don't move anything, you just put way on the end. So apple becomes appleway. So if I said pig apple, it becomes igpay appleway. Right? So here's an example. This is a sentence that I've encrypted in Pig Latin. Eleway, Aime, Aimne, Isway, Istre, Andway, Elcomway, Ute, Iwe, Ijtilde, Onime, Evolution Ray. Right? Now if you hear that and you see that, and also I didn't use any voice tone there, you may not have any clue what that means. Whereas if I look at this version of the message, this is the encrypted version. Whereas this is the unencrypted version. That actually says, hello, my name is Chris and welcome to the Digital Money Revolution. But I ran it through Pig Latin, and that first example there is the same thing in Pig Latin. So when we say encryption, that's where cryptography comes from. We've made it cryptic. We've made it vague. Now, Pig Latin, in Pig Latin, the rules that I showed you in the previous slide, the rules is called the encryption key, okay? Because that's the thing that's the key that unlocks the message. So that if you didn't know the rules of Pig Latin, you would have no idea what that first message meant. So here's how this applies to Bitcoin. I've just basically given you the concept of encryption there, how to scramble a message to make it appear meaningless. But let's say we've got two computers and they're connected together, and this first computer wants to send some Bitcoin to the other computer. And then let's say while they're doing that, a hacker manages to snoop on that. So they manage to see the message as it's being communicated from one computer to another. And say they manage to get a copy of the message as it's traveling from computer number 1 to computer number 2. Now, because these two computers are using encryption, the computer sending the Bitcoin transaction encrypts the message first. All the hacker would see is just nonsense. It would just be a scrambled mess, and they wouldn't know what the hell was in it. And that's because, like I said, both computers will be using a key to scramble the message. And unless the hacker knew what the key was, the message is completely meaningless. So everyone in the world could have a copy of the message. Unless they have the key, they don't know what it is. So that is cryptography in a nutshell. It's a method that's used to scramble a message so that it looks meaningless while it's traveling. Okay? And then when it gets to the other side, say I receive it, I use the key, I unencrypt the message or decrypt it, and then the message is meaningful again. And unless you know the encryption key, there's no way to know what the original message was. You may not even know what format the original message was in. You don't even know if that scrambled mess was originally numbers or images or words. You don't even know if it was words. You don't even know what language it was in. And those elements, to tell you whether it was numbers or what language it was in, whether it was English or French or German or whatever, those bits of information might not be even included in the message itself. So if you and I agree earlier on that we're always going to send messages in English or we're always going to send them in German, we agree that and we know that. So then when we write the message, we write it in German, encrypt it, and just send the encrypted message. So say a Spanish person did manage to decrypt the message. Well, they wouldn't know what it was, because if they don't know German, then it's still meaningless. Because even German is kind of an encryption in a way. You have to understand how to translate the meaning into something you understand, if that makes sense. And finally, if the type of encryption becomes less secure for some reason, say as technology moves on, say some new computer technology becomes available that can potentially attack or beat the encryption that Bitcoin uses. Well, Bitcoin is open source, so we could just get a newer type of encryption and propose it to the network, agree it, and then implement it. So in the future, when that new piece of computing technology is created, the one that might break the Bitcoin encryption, by that time there'll be new encryption methods. And because Bitcoin's always evolving, if everyone knew that the Bitcoin network was starting to become unsecure because the cryptography was out of date, then someone could propose a new method. Everyone could look at it, agree that it was good for the network, agree that it was more secure and more modern, and then we could implement that. So Bitcoin is not fixed, it's always evolving. And it's in everyone's interest to keep it evolving because everyone's money is going to be based on it. So that's the basis of cryptography, and that's how it works in the Bitcoin network. We're going to come back to cryptography later when we get onto the Bitcoin with a small b, because at the minute we're looking at the technology side of things. When we get onto the currency side of things, which is Bitcoin with a small b, then we're going to look at currency, we're going to look at wallets, and we're going to look at mining and all that kind of thing. So cryptography is going to come back again, and we're going to dig into it again. But now we understand the concept, we won't have to go over that again. We'll just be able to show how it applies to currency and Bitcoin. Okay, that's all for this lesson. Hope you've enjoyed that. Let's move on to the next lesson. So it's bye for now.